Welcome to the last video for stoichiometry, where we're going to go into how to do a limiting reagent. And you can see underneath the very top of our title, a limiting reagent is also known as a limiting reactant. And so reagent and reactant can be used interchangeably. So if you haven't heard reagent before, I just want to make you aware that this is also considered a limiting reactant. You can see below our title that we have two different definitions here that I think are of importance for you to understand why we're going about figuring out what the limiting reagent is. And you're also going to see things like a reactant will be in access, and so you need to know what that means as well. Up until this point, we really have been saying that things have been in access, so you might have seen that in your directions, but not really noticed it or known what it meant, but you will after this video. So, first of all, limiting reagent is the reactant that determines the amount of product that can be formed from a reaction. Let's go over to the next definition, and we'll kind of talk about them interchangeably and figure out exactly what that means. So for an access reagent, the reactant that is not completely used up in a reaction. So the example that I like to think about with my class is if you can hold something in your hand, that would be considered a reactant or a reagent in this case. And you think about it reacting with oxygen, so the O2 that's in the air around it. Just physically in the room that you're standing or sitting in, that is a lot of oxygen around what could be held in your hand. And so there's that unlimited amount of oxygen that's around it. So when we're looking at limiting versus access in that example, hopefully it's clear that the oxygen is in access. We have plenty of it. There's no way that the oxygen is going to hold our reaction back. What will hold our reaction back is the amount that is held in our hand. Okay, and that would be considered what is limiting, and so that would be the limiting reagent, is what would be in our hand versus the oxygen. So let's go ahead and go into a problem. I'm going to show you first a balanced chemical reaction, and the first step to stoichiometry problems, if you have a reaction given to you, is to make sure it's balanced. So that step is going to be taken care of. The wording of the problems can change slightly, so just pay attention to how the wording is and write down a few visual clues that can help you out as you go through the problem. Up on your screen now you can see the balanced chemical reaction on our first line. Sometimes it will be underneath some of the wording that's given to you. But let's go ahead and read through our directions. It says, given the balanced chemical reaction above, how many grams of copper 1 sulfide can be produced by the reaction of 80.0 grams of copper with 25.0 grams of sulfur. So I'm going to write a few visual cues underneath my balanced chemical reaction to show this information. So now in pink you can see how I wrote down how much of each reactant I have, and then I put a question mark for grams underneath the product that we want to find out. When we're given the amount in grams or even in moles of our reactants, we have to figure out which one's going to limit our reaction first. Notice that the directions don't actually ask you to find that. Some will come out clearly and say find a limiting reagent before you proceed, and others will just go ahead and say you have certain amounts of your reactant. If you're given a certain amount in grams or moles of your reactants, you need to figure out which one's limiting first before you proceed and do the rest of the problem. So with that being said, let's go ahead and set up our problem. When we're doing a limiting reagent, the first thing is going to be figure out how many moles of each one of our reactants we have. And so if you start with moles, that step will be done. So let's go ahead and see what that will look like. So now on your screen you see LR, which is the abbreviation for limiting reagent. So you might see teachers throwing around LR on their boards or in problems worked out, and that's just limiting reagent. And so to do the limiting reagent, we have to take each one of our reactants and set up a dimensional analysis to get to moles. And so you can see here that I clearly labeled that the top one is my copper reaction, and the bottom one's going to be my sulfur reaction. And to get to moles, I want to go ahead and divide by my molar mass of each one of those. And that should be pretty straightforward because you have just simply copper, look it up on the periodic table, and sulfur, and look that up on the periodic table. Before I went ahead and calculated this and finalized what the mole amount would be, what we need to be aware of is the molar ratio between our two limiting reagents. So before we go ahead and calculate what our answers are here, we do need to figure out one more thing before we can figure out exactly which one is going to be eliminating our reaction. And that is going to be comparing our mole-to-mole ratio. So if we had a mole-to-mole ratio that was 1:1 or simplified down to 1:1, we could go ahead and do this step and compare the two numbers because they have a 1:1 ratio. But of course, we don't always have a 1:1 ratio. How am I going to figure out if I have that ratio or a different ratio? That's going to come from our balanced chemical reaction up here. We have, for every 2 grams of copper, 1 mole of sulfur is needed. And so we have a 2:1 ratio between copper and sulfur. Because of that, we have to take that into account and change one of the two of these to the other. Just to be very clear, I went ahead and added a starred note. So in pink, I have here, pick one of the reactants and convert to moles of the other reactant, if not 1:1. And it really doesn't matter which one you go ahead and do. So in this example, copper, sulfur, you can go ahead and convert, and I'll show you how to do that. It really is just a mole-to-mole step that you'll add. But I always just pick the first one that I have listed. And so copper is my first one listed. And so I'm going to go ahead and do a mole-to-mole conversion between copper and sulfur to my first dimensional analysis. So let's go ahead and get that taken care of. So here on your screen, you can see the last step that I added to the first one. And that is going to be, for 1 mole of sulfur, I'm going to have 2 moles of copper. And again, the 1 and the 2 come from the 1 on the sulfur and the 2 on the copper. And this is my mole-to-mole step that I was referring to before. So now I want to go ahead and calculate both of these dimensional analysis numbers, and we can compare and see which one is smaller. You can now see on the screen what the numbers are if you calculate them. And you can directly compare these numbers now because they're both in moles of sulfur. So when you compare the two, whichever one is smaller, such as the top, will be our limiting reagent. We need to be clear here though, with this being the limiting reagent, it's not sulfur that's the limiting reagent because this number came from copper. So copper is our limiting reagent. So I'm going to write a little note under LR that copper is really the one that's limiting this reaction. And so here you go. Limiting reagent is copper. At this point in time, you can continue on with the same type of stoichiometry that you have been learning in your other videos. The only thing that we need to do is once we figure out our limiting reagent, we have to use the limiting one to do the rest of the problem. And so let me show you what that's going to look like. So here at the very bottom of your screen, you can see that I started with the copper to start my problem. And I, in my problem, wanted to get to copper sulfide. And so if you need to, go back and you can reread through the directions of this problem. But we did want to convert to copper sulfide and figure out how much we could get from this reaction. And so taking our limiting reagent to start out with, which is our 80.0 grams of copper, we want to go through the gram to mole conversion, the mole to mole conversion, and the mole back to gram conversion to get our final answer. And we want to make sure we have sig figs. We started with 3 sig figs, so we need to end with 3 sig figs here. And that's how we get our scientific notation so that those 2 zeros count in our significant figure amount. At this point, of course, we are done with all of our stoichiometry videos, but we can go ahead and mix things in here. And so not only can we do a limiting reagent and then figure out what our theoretical number would be. Notice I said our theoretical number. If I gave you an actual number at this point in time, you could figure out a percent yield if I gave you the actual number. Some other things you could go ahead and do would be, instead of going to grams, you could have gone to molecules of copper sulfide. And there's a couple different other possibilities as well. So use the videos to help you out. Take notes on all of them, because at this point in time, you really can do all the stoichiometry problems that are thrown your way. Remember, you always need a balanced chemical reaction.